Let's look at finding a confidence interval for the mean when the population standard deviation sigma is unknown using a TI-83 or TI-84. For example, construct a 95% confidence interval for the mean number of pets in the households of college students. Suppose that a sample of size 47 students yields these values: 1, 1, 0, 2, 1, 0, 1, 0, 2, 1. I'm not making these up. These are actual data from a couple of classes. We have way more than that. Our family has 7 pets. We've got 4 cats. So there's Moose, there's Bean, there's Cupcake, Pumpkin. We also have 3 chickens. Sunny, Mei Li, Chinese breed is silky, kind of fluffy, and Priscilla. Okay, so here's how we do it using a TI-83 or TI-84. Press Stat, that's this button, and then choose Edit. And then we enter the data into list L1. So 1, 1, 0, 2, 1, 0, 1, etc. Then when we're done with that, we press Quit, which is second and then Mode. Quit. Okay, so going back to Stat, press Stat. And this time, instead of Edit, choose Tests. And under Tests, use T-interval. Okay, so stat, test, T-interval. The input in this case is data. So it's not stats, it's data because we have the raw data. Sorry that you can't see that very well, but sometimes life is like that. You have the raw data, so choose data under input. And you put the data in list L1. The frequency is 1. That's because sometimes we have a frequency table. So if instead you had list L2 as the frequency, let's say this appears so many times, this appears so many times, this appears so many times, and that frequency list run L2, you'd put L2 here. But you don't have that. You just have a list of raw data in L1, so your frequency is 1. Confidence level is 0.95, and then press Calculate. And this is what we end up with, 0.964, 1.84. Okay, now let's construct a 95% confidence interval for the mean number of pets in the households of college students. But suppose that you don't have the raw data, but have just the sample statistics. A sample of size 47 students yields these. So x bar, the sample mean, is 1.40. S sub x, the sample standard deviation, is 1.5. No raw data, just the summary statistics. We can handle that. So using a TI-83 or TI-84, again, we press Stat, as before. Tests, T-interval, just like before. But this time, instead of the input being data, the input is stats. Because we don't have the raw data, we have the stats. X bar, the sample mean, is 1.4. S sub x, the sample standard deviation, is 1.5. N is 47. It's the size of the sample. Confidence level is 0.95. And you get 0.960, 1.84 as the answer. Notice that that's slightly different from what we had earlier as the interval, and that's because we rounded x bar and s sub x. So when we entered the raw data, we had a more accurate sample mean and sample standard deviation. Here, rounding leads to a less accurate answer, but it's still pretty accurate. Okay, let's construct a 90% confidence interval for the mean. Everything would be the same, except now the C level, the confidence level, is 0.90. Press Calculate, and you find that the confidence interval is 1.03, 1.77. Notice that that's smaller because we're only 90% confident that the true population mean is in there. If we want to be 95% confident, as we were a moment ago, then we need a wider interval. By the way, the American Veterinary Medical Association lists these as the most common pets in American households. Just a little under half of American households have a dog. We used to have a dog, a Tibetan Spaniel named Lola. About a third have cats. 2.9% have fish. Reptile, 1.8%. We used to have a bearded dragon, fun little creature. Bird, 1.6%. Small mammal, like a gerbil, a hamster, etc., 1%. We used to have a dwarf hamster named Pip. Rabbit, 0.7%. Horse, 0.5%. And poultry, we've got those in spades, 0.5%.